Hello guys, good afternoon. So we are now in part number 4 of our solid design principle. So this is number 4 guys, and this is what we call ISP. ISP or Interface Segregation Principle. So this is number 4 of solid design principle. So ISP state that client client should not be forced. So you should not force your client to implement an interface that it will never use, or interface is irrelevant to it. Okay, this is the definition. So to fully understand guys, we should give a sample demonstration guys. Okay, so I will just have to create an interface here, public interface. So this is just a simulation for this solid principle number four. For example, I have a vehicle here. So I have an interface vehicle here. So this vehicle I could have a signature of Boyd drive, and I can also have a signature Boyd fly. Okay. So I have two signature for the interface I vehicle. All right. So when I'm going to this error top level, we just comment this out. This is our ISP, or just deleted it. Yeah. Okay. It's the implementation. All right. So this principle states that a client should not be forced to depend on methods it will not use. The principle promotes the implementation of many small interfaces. Instead of one big interfaces, it will allow client to select the required interfaces and implement the same. So if you have a big common interfaces, maybe you can just factor it out or refactor it into very smaller interfaces, that there will be no method that is not irrelevant when you are going to apply it or you are going to use that interface. So that's the goal of this principle, to break the software into smaller classes that do not implement that interface or method that will not be used by the class. This will help us in keeping the class focused, learn, and decoupled from dependency. So the interface which is implemented by class should be closely related to the responsibility. So something like a single responsibility as well, right? So this is a relation to the first solid principle that we have. So to 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 have a clear example, I am creating here an interface of iVehicle. So basically, if we are going to create the implementation class, for example, public class, and I should have uh, yeah, I will just have a car, and I will inherit the iVehicle because car is part of iVehicle, right? So when you implement that, you will have the drive and the fly implementation. So we implement this, for example, this is, we just say console, right line, driving, driving a car. Let's say, for example, like that. So this will drive a car. And this one, fly, we can have just like console that right line. The car is flying. So do you think there's a car that will fly? So this is the problem here. Yeah, because this is the violation of ISP. Violation of ISP principle. Okay, so if you have a car and then so basically there's no the car cannot fly. So what you have to do here, you will uh, throw new not implemented. So just like throw new throw new exception, throw new not implemented exception. I mean, just like that because there is no car that will fly, right? So what if for example you have a implementation class or public class, then this is a flying car. So if you have a fly car, so it will be okay. So because that is specified that it is a flying car, so you can have that like that. But uh, yeah, something like that. So yeah, all right. So that's okay. So it's stated that a client should not be forced to implement an interface. So we, for example, this car. So if we instanted this or if we use this class, we should not uh, we should not uh, have this signature because it's irrelevant because the car cannot fly. Something a design like that. So in the real world, if you have application design that in an interface is not applicable during the implementation implementation class, so you have to refactor it into small interfaces. All right, so that's the issue of HRP. So how we are going to solve it? We are going to The solution is to apply solid ISP interface segregation principle. We have to make it into smaller interfaces. So for example, from that example, we can have public interface. Let's see, iDrive. So this is just interface for uh, a Boid. You have signature Boid. This is just for and then you can also have interface for iFly like that, and then you can have the signature Boyd fly like that. All right, so that is the broken down of the interfaces. This is just example simulation, but in real world you have to take note of this. So this is just for us to follow. For example, now if we have let's back with our this one. This car, public car, we are not going to implement a vehicle because this is big enough. Let's violate our design principle. So instead of inheriting the I vehicle, we are now going to inherit the small interfaces, which is drive. Okay, which is drive is only have. So this is not included because the drive now for the car uh, titular type interfaces. So iDrive only have one signature, which is only drive. So as well as this one, fly car, we can make it, can derive it from the I fly. So there's no drive here, something like that. Okay. So if you have another implementation, for example, there is a combination of uh, flying car, for example, there's an invention that a car can fly. So you can just create flying cars, and then you can uh, this is in this is a class flying car, and then you can inherit from iDrive, which have drive method, as well as you can inherit from the iFly, which has a fly method. So this is a multiple inheritance. Okay, we implement that. So what's happening here? Reply is not this is the fly. So why is because we need to get rid of this, because this is a violation. So uh, violation of especially just comment it out. It seems it's not working out. So drive. So I have no interface of iDrive. This here. Delete this first. So iDrive happiness is flying car. This is not working. Okay, so it's we have create interface drive, and we have also interface I apply. So when we have a flying car, let's start first with the car. When we have an implementation class for a car, we only inherit the iDrive. Okay, so it will only have, does not implement. Okay, we implement that. It's only have a drive. Okay, so this is driving. Okay, and if you have another implementation class for uh, flying, for example, fly, you just inherit the I fly. All right, so you only have one method here. So that is because they have the same. So maybe we can flying like that, so it will be different. Edit this. Yeah, you have fly method only, and this is a flying car example. Now if you have both, so a car that can fly and a car that can drive, because there are technology that does the car will fly. So you have implementation of flying car. First, you have to inherit the iDrive. Okay, so this is class, and of course you have to inherit also the iFly like that. So all of this you can implement if we'll have a two method, something like that. All right, so by breaking the iVehicle into smaller interface, now you are adhering to the uh, ISP or interface segregation principle. Yeah, so you can say that uh, because it's big enough, if it's I vehicle, then uh, you are creating, you are when you create a car, it will have a method flying even if the car is not have no functionality to fly. So the solution for the solid design principle is to break down that big interface into a smaller one, just like this illustration. So earlier we created iVehicle with two methods, drive and fly, but now we make it into a smaller interface. We have iDrive that can only drive and iFly that can only fly. And then the implementation car that will drive, he has only that method. He just only inherit the iDrive interface. And the flying car, it's only inherit the iFly interface. So it can only have that method fly, right? But we know that there is a flying car. So the implementation of flying car, for you to have the two method that can drive and that can fly, so you have to have a multiple interface. So you inherit the iDrive and the iFly. So that is interface segregation principle. So I hope you learn a lot from that, guys. So in our real scenario project, we have to take a look at that because most of the time we bypass this principle, which can help us in the later and the maintenance of the software. Because as a software developer, for myself example, I didn't consider the design principle in the earlier years. What I focus is that I can make it work well in your client in the business. They don't know, they don't care on your how do you implement. What just they care is if it works or not from the requirement. But for us as developer, especially if we are in team developer and we want that it will be extendable or it will be maintainable, yeah, our coding or our design principle, then I think this is a must to follow the solid design principle. So the benefits of ISP, enterprise segregation principle, by implementing smaller interfaces, we're able to separate responsibility. So it's also related in a single uh, responsibility. Is RP single responsibility principle in our first principle of the solid, right? By implementing smaller interfaces, we are able to distribute responsibility among multiple interfaces, and thus we achieve a better abstraction. Yeah, so that's classes can use relevant interface and thus implement functions that are required by the classes. So, for example, flying car, he can use the relevant interface because if we have flying car and just we just enter we just for example we have a flying implementation and we inherit the iVehicle that we created earlier, so it's not relevant anymore to have the meter fly. I drive, I meant. At the same way, we have car, it's not relevant anymore to have meter fly because this car is not having a fly functionality. So it seems like that. So in real world example, I can say that the enterprise segregation is in the e-commerce. So e-commerce platform. So I've been part of the e-commerce development project. So whereas but we are lots of developers working together. So you cannot initiate the solid principle that you want. But in a part that I am doing it as much as possible, I also consider this design principle. For example, in e-commerce, there is an order entry option. We have multiple options for payment of the order. Instead of implementing one big interface for payment option, we can break down the payment interface into smaller interfaces based on the payment type. For example, if the payment type is by 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 Bitcoin or by Gcash or whatever, so we can make it a very smaller interfaces instead of making a big interface with high payment method like that. So implementing multiple small interfaces based on payment type can implement those order classes based on the type of order. So it's something like that, guys. So, oh, So this principle promotes the use of small interfaces instead of one large interface. So one large instrument might be convenient from a coding perspective. Of course, it might be convenient, but might end up with more than one responsibility in a single interface, which is difficult to maintain. So our goal here is to maintain easily. So maintenance is part of our goal. So yeah, so that's it for the enterprise segregation principle, guys. I hope you learn a lot, and as also I am also learning this. So don't forget to subscribe and hit the bell button. So the next video will be the fifth and the last solid principle, which is the dependency injection inversion principle. All right, guys. So don't forget to subscribe and hit the bell button now, and see you in the next video. Happy learning, guys. Bye bye.